Hello, so in this video today we're going to be looking at solving cubics using the factor theorem. Now if you're not sure about the factor theorem, I have another video on that which you can go and see. But just as a quick recap, the factor theorem says that if f of a equals 0, then x minus a is a factor of f of x. Now this means when you substitute into a polynomial a number a, and if the answer you get out is 0, we can say that x minus a is a factor of f of x. That means that x minus a divides exactly into f of x without any remainders. Now we're going to use this to help us factorize cubics. So consider this question. Consider f of x equals this, and we know using the factor theorem that x plus 1 is a factor. We can then factorize f of x further. Now you might be given this, or you might have to find it. So to start with, if you had to find it, as we said in the other video, what you would do is substitute x equals 1, or x equals minus 1, x equals 2, x equals minus 2, until you found one where f of your number gave you an answer 0. Now there's two ways to go from here. One is to use algebraic division, and again there's another video on that, or to use inspection. Actually inspection is easier. Most people prefer inspection to algebraic division, but it does take a little bit of practice to get confident with it. Okay, so first of all, just so we remind ourselves of algebraic division, I've done this by algebraic division. So we have said that x plus 1 is a factor of our number. So that means that x plus 1 divides exactly into this number, and what you would have then left over would be another factor of this. So we start with how many times does x plus 1 go into x cubed? We look at our leading term. We want that to become x cubed, and we're at x. So what we do is multiply it by x squared. And so if we take this term here and multiply by x squared, we get x cubed plus, expression x cubed plus x squared. Then we take them away. X cubed minus x cubed is 0. 6x squared minus x squared can be 5x squared. We then bring down the next term, which is 11x. And then again, we look at our leading term here. So we've got 5x squared. What would I multiply this x by so I can get that bit to disappear? I'd multiply it by 5x, so I write 5x up here. And so that gives me 5x squared plus 5x. I take away again, so 5x squared minus 5x squared is 0. 11x, take away 5x will give me 6x. I've still got another term, so I bring down my 6. And then I look at this and say, oh, what will I multiply this x to get 6x? I multiply by 6. So that gives me 6x plus 6. I get nothing left over. And I wouldn't expect anything to be left over because this is a factor. So there's no remainder. It goes in exactly. So then we can say that x cubed plus 6x squared plus 11x plus 6 factorizes to be x plus 1 times this bit up here. Times x squared plus 5x plus 6. So if we multiplied this back out, we should go back to this. Now we can actually now factorize further, and if it says it's got to be fully factorized, you would need to factorize further. So this factorizes into x plus 2 and x plus 3. You should be able to see that by now. So 2 times 3 would give you the 6, and then 3x plus another 2x gives the 5x. Okay, so that's one way of factorizing completely. And then the second way is by inspection. So this just takes a little bit of getting used to. So what we say is, this is what we've got. This is one factor. So what we should be left with, because the highest power here is cubed, and we got this x here, is a quadratic. Now we look at this, and we start with the highest power, x cubed. And we say, well, what would this a be such that I end up with just 1 x cubed? So if you do x times ax squared, which will give you ax cubed, what would a be? So we just had 1 x cubed. So a would obviously be 1. Now the next one is slightly harder. So now we want to look at this. How would I get 6x squared? So I look at this and say, what in all of this is going to generate an x squared for me? Now I can see I've already got this 1 and x squared, so that's 1x squared. How many x squareds do I need? I need 6. So I need another 5. Now where else am I going to get x squareds from? And I look and I see there's x there and bx there. So x times bx would give me bx squared, and I want that to give me 5, so that in total I've got 6x squared. So we can see from that that I want 5, so b must equal 5. And then the last one, actually, I do sometimes do before the one above because it's nice and simple. I want to get 6 here. What's going to just generate a constant with no x's in? It's only going to be the 1 times the c, so the c must equal 6. Now if we multiplied all this out, we need to be sure that we would also get this 11x, and because we know they're both factors, it will be 11x, but it doesn't do any harm to check. So where would I get 11x from? So I'd get 1 times my 5x, and then I would get the 6 times that x times 6. So 5x plus 6x would give me 11x, so it works. Again, if I want to factorize fully, I do need to factorize again into the double brackets. Anyway, I hope that's helpful. The inspection is easier if you can get used to doing it. Okay, thank you.